Geometry. We are back with another video, and in this lecture we will discuss how to solve radical equations. As in the previous video we will learn how to solve radical equations. Now in this lecture learn how to solve radical equations having two radicals. So check out the rules how to solve it. First of all, isolate the radical. So the first step is x plus 2 under root, which is equals to 3 minus, we take this radical on the right hand side, so we have x minus 1 under root. And the next step is to remove the radical sign, so we take the square on both sides, so x plus 2 under root square, and square with this whole term as 3 minus x minus 1 under root in square. So as this square is cancelled out with this under root, so we have x plus 2, which is equals to, and in this form we will open the formula a minus b square, which is equals to a square plus b square minus 2ab. This formula 3 square plus b square means x minus 1 under root with square and minus 2a and x minus 1 under root x plus 2, which is equals to 3 square, which is 9, plus, and this square is cancelled out with this under root sign, so we are left with this term, and minus 6x minus 1 under root. Now to simplify these terms, this x can be cancelled out with this x, so we are left with x minus 9 plus 1, which is equals to minus 6 x minus 1 under root. Now after simplifying with minus 6, which is equals to minus 6 x minus 1 under root, 6 which is equals to 6 x minus 1 under root. Our aim is that to remove this radical sign and take the square on both sides. So we have 6 square, which is equals to 6 x minus 1 under root square. Now it will be 36 is equals to 6 square. This means, this step means this term. So 36, which is equals to 36 x minus 1. Now 36, which is equals to 36x and minus 36. 36x, so 36 plus 36, so 36x, which is equals to 72, and the final is x is equal to 2. So now to check out that the value of x is a solution set or the extraneous root. Now as we put the value of x, which is 2, in equation first, which is original equation, so 2 plus 2 under root plus x, which is 2 minus 1, which is equals to 3. Basically we verify this equality, that this equality holds or not. So it will be 4 under root plus 1 under root, which is equals to 3. It will be 2 plus 1, which is equals to 3, implies that 3, which is equals to 3. So it is valid solution. Solution set which is equals to 2. Here is an example to solve the radical equations having two radicals. So if you like this and subscribe, now move on to the another example. So we take a square on both sides as x plus 3 under root square, which is equals to 2x plus 1 under root minus 1, and this term is whole in square. X plus 3, which is equals to, as in this step we apply the rule formula, which is a minus b square, which is equals to a square plus b square minus 2ab. The formula as x plus 4 under root square plus b square 1 square minus 2a and b. 2x plus 4 under root is x plus 3, which is equals to 2x plus 4, and square of 1 is 1, and minus 2x plus 4. Minus x minus 2, which is equals to minus 2x plus 4 under root. Common minus in this term, so we are left with x plus 2, which is equals to minus 2x plus 4 under root. Step is x plus 2, which is equals to 2x plus 4 under root. As our main aim is to remove this radical sign, so for this we take squares on both sides again. 2x square, which is equals to 2x plus 4 under root and square. Now opening the square by formula, by using this formula I have x square plus b square plus 2x into 2, and after this we have 2x plus 4. Now opening this we have x square plus 4 plus 4x is equals to 8x plus 16. X square minus 4x minus 12, which is equal to 0. We apply the factorization method. So as a factorization method, first of all we have to find the multiples of the factor 12. So if we divide it, 2 6 and 2 3s are 6 and 3 1s are 3. If we take 6, 3 2s are 6 and the other one is 2, and we need a negative sign, so we put the negative sign with the larger number 6 and plus. So after applying the addition operation we have minus 4, and in multiply these two terms we have minus 12. So we find these two factors, so we can write as x square minus 6x plus 2x minus 12, which is equals to 0. Now taking common x, so we have x minus 6 plus 2 common in these two factors, so we are left with x minus 6, which is equal to 0, plus 2, and the common factor is x minus 6, which is equals to 0. So x plus 2 is equals to x minus 6, which is equals to 0. So subtract minus 2 on both sides, so we have x is equals to minus 2, or the other case is x is equals to 6. Here, now we check out that these two values of x are the solution set or the extraneous root. For the given equation is in A equation, and put the first value of x, which is minus 2, in equation A. So we have minus 2 plus 3 under root, which is equals to, we have to verify this equality, 2 into minus 2 plus 4 under root and minus 1. So we are left with 1 under root, which is equals to minus 4 plus 4 under root, which minus 1, and under root of 1, which is 1, and this will be a 0 minus 1. So we imply that 1 is equals to minus 1, which is false. The extraneous root. So we have the value of x is 6 plus 3 under root, which is equals to 2 into 6 plus 4 under root minus 1. 9 under root, which is equals to 12 plus 4 under root minus 1, and this implies that 3, which is equals to, will be a 16 under root and minus 1, and after this step 3 is equals to 4 minus 1. This implies that 3, which is equals to 3. So it is valid. X, which is equals to minus 2 is extraneous root. So we can write the solution set, which is equals to, which is 6. So its solution set is 6.